You've heard the saying, lightning never strikes the same place twice. It's a comforting thought, suggesting some kind of cosmic rulebook protecting us from repeated disaster. The idea that once a place has been hit, it's somehow immune to future strikes gives us a false sense of security. But like many catchy phrases, it's simply not true. Lightning can and does strike the same place more than once. The universe doesn't keep a tally of lightning strikes. There's no cosmic ledger ensuring that once a place has been hit, it won't be hit again. It doesn't offer special protection to any particular spot on Earth. Every location is equally vulnerable to the whims of nature. Lightning, as we'll see, follows the laws of physics, not superstition. The paths it takes are determined by the conditions in the atmosphere and the ground. In reality, lightning can, and often does, strike the same place twice. Tall structures like skyscrapers and towers are particularly susceptible. In fact, some locations are struck with surprising regularity. The Empire State Building, for example, is hit by lightning around 20 times a year. Understanding why this happens requires a closer look at the science behind these electrifying events. The formation of lightning is a complex process involving the buildup of electrical charges in clouds and the ground. When the difference in charge between the cloud and the ground becomes too great, a lightning bolt forms to balance the charges. This process can repeat multiple times in the same storm, leading to multiple strikes in the same location. So, the next time you hear someone say that lightning never strikes the same place twice, you can confidently tell them that science says otherwise. Lightning is unpredictable, but it follows the rules of nature, not the rules of catchy sayings. Lightning is a dramatic release of electrical energy. It's one of nature's most spectacular displays, a powerful reminder of the forces at play in our atmosphere. But what exactly causes this brilliant flash of light and the accompanying thunderous roar? It all starts within a thunderstorm, where churning air creates static electricity. These storms are like massive electrical generators with updrafts and downdrafts moving air around at incredible speeds. As the air moves, it causes collisions between tiny particles of ice and water within the cloud. This electricity builds up within the cloud, creating areas of positive and negative charge. The collisions between particles cause electrons to be knocked off, leading to a separation of charges. The top of the cloud becomes positively charged, while the bottom becomes negatively charged. Think of it like a giant battery in the sky. Just as a battery has a positive and a negative terminal, the thundercloud has regions of positive and negative charge. This separation of charge creates a potential difference, much like the voltage in a battery. The difference in charge between the cloud and the ground below creates an electric field. This field is invisible, but it's there, stretching from the cloud to the ground, waiting for the right conditions to release its energy. This field grows in strength until it overcomes the insulating properties of the air. Air is normally a good insulator, but when the electric field becomes strong enough, it can ionize the air, turning it into a conductor. When this happens, a massive spark jumps the gap. That's the lightning bolt we see. This spark can travel at speeds of up to 220,000 miles per hour and can reach temperatures of around 30,000 Kelvin, which is 5 times hotter than the surface of the sun. It's a sudden, powerful surge of electricity, capable of heating the air to temperatures hotter than the surface of the sun. This rapid heating causes the air to expand explosively, creating the shock wave we hear as thunder. Lightning is not just a visual spectacle. It's a powerful reminder of the dynamic and ever-changing nature of our planet's atmosphere. So why would lightning strike the same place twice? Think about magnets. Opposite poles attract, right? Lightning behaves in a similar way. Tall objects like skyscrapers or trees create a pathway of least resistance for the electrical charge to reach the ground. It's like laying down a welcome mat for a bolt of lightning. This is also why lightning rods are so effective. They are designed to attract lightning strikes and safely channel the electrical current into the ground, protecting structures from damage. Take the Empire State Building, for example. This iconic skyscraper, standing at 1,454 feet tall, is not just a marvel of human engineering but also a frequent target for nature's fury. It is struck by lightning an average of 25 times per year. The building's height and its steel structure make it a perfect conductor for these powerful electrical discharges. It stands tall, a beacon in the storm, attracting those powerful bolts. The lightning rods installed at the top of the building are designed to safely channel the electricity down to the ground, protecting the structure and its occupants. Another striking example is Lake Maracaibo in Venezuela. This massive lake, surrounded by mountains, creates a unique microclimate that is perfect for thunderstorms. It experiences an average of 297 thunderstorms per year, with lightning flashing across the sky almost constantly. The phenomenon is so regular that it has been given a name: the Catatumbo lightning. This natural light show can last up to 10 hours a night and occur up to 260 nights a year. The lightning is so intense that it can be seen from over 400 kilometers away. It's known as the lightning capital of the world. The consistent lightning strikes are not just a spectacle but also play a crucial role in the local ecosystem, helping to fix nitrogen in the soil. These locations demonstrate that lightning doesn't play favorites. It strikes where conditions are most favorable, whether it's a towering skyscraper in a bustling city or a remote lake in the mountains. It simply follows the path of least resistance, seeking out the tallest and most conductive objects in its path. This is why we often see lightning striking tall buildings, trees, and even people who are caught in open areas during a storm. Tall, conductive objects are like superhighways for electrical discharge. Understanding this can help us better protect ourselves and our structures from the incredible power of lightning. Scientists have been tracking lightning strikes for years, mapping their frequency and locations. These maps show us that certain areas are more prone to lightning than others. For example, Florida is known as the lightning capital of the United States, with a high density of lightning strikes each year. This is due to its unique geography and weather patterns. These maps help us understand lightning risk and inform safety guidelines. They also confirm that lightning doesn't discriminate, it strikes where it will, often returning to the same areas repeatedly. Knowing that lightning can strike the same place twice underscores the importance of lightning safety. When thunder roars, it's time to take cover. Seek shelter indoors or in a hardtop vehicle. Stay away from windows, plumbing, and electrical appliances, as these can provide a pathway for lightning to enter a structure. Remember the 30-30 rule? If less than 30 seconds pass between a lightning flash and the sound of thunder, the storm is close enough to pose an immediate threat. Wait at least 30 minutes after the last clap of thunder before resuming outdoor activities. The myth that lightning never strikes the same place twice is just that, a myth. It's a comforting thought, but it's not grounded in reality. Lightning follows the laws of physics, and those laws don't discriminate. Tall objects, conductive materials, and areas with frequent thunderstorms are all more likely to be struck by lightning, sometimes repeatedly. While location plays a role in lightning risk, it's important to remember that lightning can strike anywhere. Even if you're not in a high-risk area, it's crucial to take precautions during thunderstorms. Be weather aware. Check the forecast before heading outdoors, especially during the summer months when thunderstorms are more common. If you hear thunder, even in the distance, it's time to take cover. Lightning is a powerful force of nature, and respecting its potential danger is the best way to stay safe. Lightning is a captivating and awe-inspiring phenomenon. It's a reminder of the immense power of nature and the importance of understanding the science behind the world around us. So, the next time you hear someone say, lightning never strikes the same place twice, you can confidently correct them. Explain that lightning doesn't play by those rules. It follows the laws of physics, and those laws tell us that lightning can, and often does, return to the same spot.